Hey everyone, welcome back. Before we dive into one of nature's most enchanting and mysterious concerts, I'm sending out a massive wave of positive vibes and heartfelt wishes to all of you watching. Seriously, wherever you are in the world, I genuinely hope you're feeling fantastic, taking amazing care of yourselves, and staying healthy. That's truly the greatest gift. Now, close your eyes for a second and imagine standing in the vast, silent expanse of a desert. The sun beats down, the wind whispers over endless waves of sand, and then, suddenly, the dune beneath your feet begins to sing. Not a whisper, not a rustle, but a deep, resonant, otherworldly humming, booming, or even musical note that seems to come from the earth itself. It sounds like pure magic, like something from a fantasy novel, but it's absolutely real. Sand dunes can sing, and it's one of the planet's most captivating natural phenomena. Forget speakers or hidden choirs. This is the desert itself performing a symphony, a rare and powerful sound generated purely by the movement of sand grains under the perfect conditions. It's haunting, beautiful, and utterly fascinating. So, what does this singing sand actually sound like? Imagine a low, powerful drone, almost like the deepest note a cello could produce, but vibrating through your whole body. Some people describe it as a loud, sustained boom that echoes across the desert, similar to distant thunder or the rumble of a low-flying aircraft. Others compare it to a deep hum or a resonant, whirring sound. In rarer cases, especially with finer sands, it can even produce distinct musical tones that sound eerily like chanting monks, a didgeridoo, or a low-flying propeller plane. The sound can be incredibly loud, sometimes reaching 105 decibels, which is as noisy as a power lawnmower or a rock concert, and it can last for several minutes, vibrating the ground and the air around you. It's not a delicate tinkling, it's a profound, physical sensation that feels ancient and powerful. This phenomenon isn't common. It only happens in specific dunes around the world, maybe 30 or 40 known locations, adding to its mystique. Places like the Kelso Dunes in California's Mojave Desert, the booming dunes near Alaskara in Oman, the Singing Sand Mountain in Dunhuang, China, or parts of the Sahara are famous for their vocal performances. Now, the million-dollar question, how on earth does a pile of sand produce such a powerful musical sound? For centuries, this baffled travelers, explorers, and even scientists. Legends attributed it to spirits, buried bells, or subterranean rivers. The truth, revealed by modern science, is even more incredible and hinges on the precise physics of sand avalanches. It's not magic, but a stunning example of how simple natural processes can create profound complexity. The key lies in the sand grains themselves and how they move en masse during an avalanche. Not just any sand can sing. The sand grains on these special dunes need to be very specific, usually well-rounded, polished by wind and water over time, and incredibly uniform in size, typically between 0.1 and 0.5 millimeters in diameter, roughly the size of fine granulated sugar or coarse salt. This uniformity is crucial. They also need to be very dry. Even a tiny bit of humidity from rain or fog can coat the grains with a microscopic layer of water, acting like glue and silencing the dune completely. The sand must also be incredibly clean, free from silt, clay, or organic matter that could get between the grains and disrupt their movement. Here's where the real symphony begins. To trigger the sound, you need an avalanche. This could be natural, caused by wind dislodging an overhang, or it could be deliberately sliding down the steep slope of the dune, your footsteps disturbing the upper layer, or even just a strong gust of wind. As thousands, millions, billions of these perfectly sized, perfectly dry, perfectly clean sand grains start cascading down the slip face, the steep leeward side of the dune, they don't just flow silently. They move in a very specific way. They form a synchronized layer, almost like a solid sheet sliding over the stationary sand beneath it, but made of individual grains. As this avalanche layer moves, the sand grains within it are constantly colliding with each other. But it's not random chaos. Because the grains are so uniform and the layer is moving together, these collisions happen in a remarkably synchronized rhythm. Think of it like this. Imagine a vast crowd in a stadium doing the wave. When everyone stands and sits at exactly the right moment, a visible wave flows smoothly around the stadium. Now, imagine instead of people, it's trillions of identical, tiny glass beads. As they avalanche, they aren't just tumbling randomly, they're bumping into their neighbors in a coordinated wave of collisions. Each collision between two grains creates a tiny click or vibration. Individually, that click is far too quiet to hear. But when billions of grains are colliding in perfect unison, all those microscopic vibrations synchronize and amplify each other. It's like an unimaginably vast percussion instrument where every single grain is a drumbeat, and they're all striking in perfect rhythm. This synchronization is forced by the pressure waves generated by the collisions themselves. A collision creates a tiny pressure wave, a sound wave, that travels through the moving layer of sand. This wave pushes neighboring grains, making them more likely to collide at exactly the same moment, reinforcing the wave. It creates a powerful feedback loop, locking the entire avalanche layer into vibrating at one very specific, resonant frequency. It's self-organized synchronization on a massive scale. The steepness of the dune slope is also vital. It needs to be just right, usually around the angle of repose, about 30 to 35 degrees for dry sand, which is the steepest angle sand can naturally pile up without collapsing. This steep angle ensures the avalanche flows rapidly and smoothly, allowing the synchronized layer to form and the collisions to happen frequently enough to build up the sound wave. If the slope is too shallow, the sand just trickles down silently. If it's too steep, the avalanche might be too turbulent and chaotic, preventing the necessary synchronization. The dune itself acts like a giant sound amplifier and resonator. The shape of the dune, the way the sound waves bounce between the moving sand layer and the stationary sand beneath it, and the open air above, all help to amplify the low-frequency vibrations produced by the synchronized collisions, turning those billions of tiny clicks into the powerful, booming hum that carries for miles across the desert silence. It's nature's own massive speaker cabinet. Scientists have worked hard to unravel this mystery. Early explorers like Marco Polo mentioned the evil spirits making sounds in the desert. Charles Darwin wrote about hearing it in Chile. But it wasn't until the 19th and 20th centuries that serious scientific investigation began. Researchers like Felix Carrier in the 1800s started experimenting. In recent decades, physicists like Stephen Doherty and his team have conducted meticulous experiments, both in the desert and in the lab. They've used high-speed cameras, sensitive microphones, and even created miniature singing dunes in boxes to study the avalanche mechanics and sound generation in detail. They've shown that the synchronization of the grains is key and that the pitch of the sound is directly related to the size of the sand grains and the speed of the avalanche. Larger grains or slower flows produce lower booms. Smaller grains or faster flows can create higher-pitched hums or musical tones. They've even managed to record the sound inside the moving sand layer itself, confirming the internal vibration theory. Hearing singing sand is an unforgettable, almost spiritual experience. It connects you viscerally to the power and subtlety of natural processes. You feel the vibration in your chest and feet as much as you hear it with your ears. It transforms a silent, seemingly inert landscape into something alive and resonant. For travelers seeking this phenomenon, it requires patience, timing, and a bit of luck. You need to find one of the rare singing dunes. You need the sand to be bone dry, which often means going during the hottest, driest part of the year, avoiding any recent rain. Then, you need to trigger the avalanche, usually by walking along the crust or sliding down the steep slip face. When it works, the reward is incredible. The dune awakens with that deep, powerful voice, a sound that feels both ancient and deeply present, a reminder that even the ground beneath our feet can hold surprising secrets and produce profound beauty. It's a moment of pure natural wonder. So, the next time you see a sand dune, remember it's not just a silent pile of grit. Under the perfect conditions, With the right sand, the right dryness, the right slope, and the right trigger, it can transform into a vast, natural musical instrument. The synchronized dance of trillions of tiny sand grains during an avalanche creates a vibration, a resonance, a booming hum that echoes the hidden physics of our world. It's a phenomenon that blends geology, physics, and acoustics into a breathtaking sensory experience. It reminds us that our planet is full of hidden symphonies, waiting for the perfect conditions to perform. From the tiniest grain of sand to the massive slope of the dune, nature orchestrates a sound that is both simple in its components and magnificently complex in its emergence. It's the desert's own secret song, a low, powerful note in Earth's grand, ongoing soundtrack, proving that wonder can be found in the most unexpected places, even in the shifting sands beneath our feet. Thanks for listening to the story of the singing sands with me today. Go out there, stay curious, stay healthy, and keep your ears open for the magic.